Good morning, AP Calculus. Today, in this video, we're going to look at how to express the equation of a line given certain properties. The first problem we're looking at is right here on the screen. Write an equation of the line with the slope of 5/3 through the point -3, -1 in slope-intercept form. Then identify the y-intercept and x-intercept of the line if they exist. What we want to do is we want to start by taking a look at the important properties of the line. First and foremost, with the slope of 5/3, okay, and through the point -3, -1. Those are all important properties that can help us figure out what that line is. Now, when we talk about slope-intercept form, we're talking about a form of a line where it looks like this. This is what slope-intercept form looks like. So y, oops, let me try writing this with a pen instead of a highlighter. So that's y equals mx plus b, okay, where m is your slope, and then b is the y value of your y-intercept, okay, which is basically the form 0b, like that, okay? But we're given a point and a slope here, so we have to use what's called point-slope form, which looks a little bit like slope-intercept form, but it's a little bit modified. Here's what it looks like. It looks like this. So it's going to be y minus y1 times m times x minus x1. Okay? Now the important parts here, you know that m is our slope, so that's not going to change. But what is going to change, though, is going to be these two parts right here, this x1 and this y1 here. Okay? And all that really is just x1, y1 is just any point on the line, which we already have. So we're going to call this -3, that's going to be our x1 value, and we're going to call -1 our y1. And obviously our slope is m. So all we really have to do is replace these three variables with the values that we know they're equal to. So that's going to look like this. So we replace y1 with -1. We replace m with 5/3. And we replace x1 with -3. Okay, everything else stays the same. So y minus y1 equals m times x minus x1. Okay, now obviously we have a lot of negatives going on here. We want to simplify those. So we're going to change this using keep, change, change, the rule that says that we can change a negative. When we subtract a negative, it becomes a positive. So plus, plus here. So now we're left with y plus 1 equals 5/3 times x plus 3. Okay. And now we're going to go ahead and distribute the 5/3. That gives me, let's see here, 5/3 times x is 5/3 x. And 5/3 times 3 is just going to give me 5. So y plus 1 equals 5/3 x plus 5. Subtract 1 from both sides, we get the line y equals 5/3 x plus 4. Okay. Now from this, we can, first of all, we can pick out what our y-intercept is, because we know that y is solved for. We know that our y-intercept is going to be whatever our constant value on the right side is. So our y-intercept, I'm going to use red for this one. Y-intercept is going to be the point 0, 4. Okay? Now to find our x-intercept, all we have to do is set y equal to 0. Just like we did with rational functions to find the x-intercept there. All we have to do is set the function equal to 0 and solve for y that way. When we do that, we get the equation 0 equals 5/3 x plus 4. So we're going to subtract 4 from both sides. So that gives me -4 is equal to 5/3 x. And then we're going to multiply both sides by the reciprocal of my coefficient. So that's going to be 3/5. So when that happens, my fractors are going to cancel out on the right side. That gives me x on the right side, and then 5/3 times -4, or 3/5, I'm sorry, 3/5 times -4, gives me this value here, gives me -2 and 4/10. That means, if I write it in orange here, my x-intercept is the point -2 and 4/10, 0. It's not exactly a whole number x-intercept, but it kind of follows the line here that we have a positive sloping line through 2 points that we can verify. Okay? Looking at another example here. Write an equation of the line through points -9, -6, and -10, 8 in point slope form. Okay, so once again, the most important point here is that we're looking at it in point slope form. Okay, which is exactly what we saw on the last page. So that's, once again, I got to write with my pen here, not my highlighter. So that's the equation y minus y1 equals m times x minus x1, like this. But in this case, we're given 2 points and not the slope. So what we want to do is we want to point out that we have to find what our slope is first. That's an m value there. Now, slope is defined as, if we were to give it a definition, it's defined as your rise over your run, which is your change in y divided by change in x. And what I mean by change in y and change in x is that if we have 2 points anywhere on a line, we can use the distance between those points to help us find the slope or the rate of change between those points. Okay? So the algebraic formula for this is m equals y2 minus y1 over x2 minus x1, where x2 or x1, y1, x2, y2, those are 2 points anywhere on the same line. Okay? So in this case, we're going to basically assign x1, y1, x2, y2 to these points here, and I'll do that in green right now. So we're just going to keep it easy, x1, y1, x2, y2, like this. Okay? So I'm going to use my formula to find this value for m. Let's use purple. Why not? I'm feeling colorful today. So m equals, so y2 minus y1. Okay, so that's going to be 8 minus -6 divided by x2, which is -10, minus -9. Okay. Once again, like we saw in the last problem, whenever we have subtracting negative numbers, we want to use that keep, change rule. Keep the first number, change the sign, change the sign. Keep the first number, change the sign, change the sign. That gives me 8 plus 6 divided by -10 plus 9. A lot easier to look at when there's not so many negatives. So let's see here. So 8 plus 6, that's 14. -10 plus 9 is -1. That means we have a slope of -14. Okay? So I'm going to replace that accordingly right here for m in my equation. So -14 goes right there. Now for x1 and y1, we already have these values defined. We define them up here. Okay? And here's what our equation is going to look like. Put that in orange once I get through this. So y1, once again, is -6. No parentheses around it. M is -14. And then x1 is -9. And then I just write everything else around it. I'm going to write that in orange. So y minus -16 equals -14 times x minus -9. Okay? So once again, we want to eliminate as many negatives as possible, especially when we subtract negatives. So we're going to do keep, change, keep the y, change that, change that. Same thing with the x in parentheses here. We're going to keep the x, change like that. That gives me, in point slope form, y plus 6 equals -14 times x plus 9. Now you can keep going. You can write this in slope-intercept form. You can distribute the -14 and get it in slope-intercept form. But that's how we find the equation of a line when we're only given 2 points. You have to find the slope first, and then you basically just replace. And if you wanted to go a little bit further, you can solve for y after you distribute. But this is as far as we're going to go for today.